So today we will be teaching you about the rational zeros theorem, which is used to solve polynomials that look like this. So the formula you have to use to find your possible zeros is the factors of the constant, which in this case is 6, and factors of the leading coefficient, which is the first rational number on the first exponent. So the factors of the constant, which are 6, are 1, 2, and 3, and 6, and they're all either positive or negative, and the factors of the leading coefficient are 1 and 2.
So the possible zeros are positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6, positive or negative 1/2, and positive or negative 3/2. And you have to plug in each one of these to find the real possible zero.
So next you have to use synthetic division to solve the problem. You have to guess and check using all your possible zeros and to figure out which one gives you a remainder of 0. So in this case, the possible zero of 2 gave us a remainder of 0. Now, we know we have one of our factors, x minus 2, so we know that's one factor of this polynomial, and to figure out the second factor, we use the remaining answers in our synthetic division problem. Now, to get the correct exponents, we start off by using one less than the largest exponent, so in this case it would be x squared, and then you go to x, and then you have your negative 3 as your constant. So here is our next practice problem. So here I have listed all the factors of our constant of 6 and all the factors of our leading coefficient, which is 2. So now I have to list all our possible zeros. So we have plus or minus, these are all plus or minus. We have 1, 2, 3, 6, 1/2. There's 2/2, but we already have that listed as 1. We're going to have 3/2. And 6/2, which is 3, and we already have that listed. So here's our list of our possible zeros. So now we have to use the guess and check method to see which one is correct. I'm going to start with 2. So now we have to use synthetic division. So as you can see, 2 does not work. So let's move on to the next one. Let's try 3. Oh, and we got a remainder of 0. So now we know x minus 3 is one of the factors of. So now we're going to talk about the end behavior of when you're graphing polynomial graphs. So when there's a positive leading coefficient, in this case there's a 4, the end behavior of the graph will be facing up. So this is just a quick sketch of what this polynomial would look like when graphed, and as you can see there's a positive end behavior. So in this case, as the x is approaching positive infinity, y is also approaching positive infinity, and vice versa. As x is approaching negative infinity, so is y.
So now we're going to be explaining the end behavior with a negative leading coefficient. So in this example, the leading coefficient is -4, so the end behavior would be facing down. It would look something like this, with x approaching positive infinity while y approaches negative infinity, and x approaching negative infinity while y approaches positive infinity.